Black holes tearing apart huge stars, pulsars that rotate at an incredible speed and emit powerful rays of energy. Colorful nebulae with fireworks of newborn stars. Galaxies of all possible colors and sizes. They are all within our universe, but it is not infinite. It has a boundary, a wall beyond which stretches absolute nothingness. And right now we're going to take a trip to that wall. Our universe is like a huge matryoshka doll. If you open it, there will be another smaller one inside. This is the galaxy. There is another nesting doll hiding in the galaxy, our solar system. And the smallest of all is the Earth. Each of the dolls has boundaries that we are going to cross. To do this, we will need a spaceship and not a small one, and it must also move 100 times faster than the speed of light. You get on board and start the engines. 100 kilometers above sea level, this is our first border. It is 10 times higher than passenger planes fly. This boundary is called the pocket line, and it conditionally separates the Earth's atmosphere from outer space. We are flying further, to the edge of the solar system. We turn on the hyperdrive and fly past Mars, Jupiter, Saturn, Uranus and Neptune and cover a distance of 100 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun, but the boundary of our solar system is more precisely the limit, the heliosphere. Here the speed of the solar wind is significantly reduced. First it drops from 1 million kilometers per hour to the speed of sound, and then in the layer called the heliopause, the wind almost disappears. And then our ship is covered by a bow wave. We feel the force of the interstellar wind, which collides with the boundary of the solar system. After crossing this border, we find ourselves in the darkness of interstellar space, where you can find 2 man-made objects that made this journey for the first time in history. The Voyager 1 and Voyager 2 space probes. Voyager 1 crossed this border in 2004, and Voyager 2 in 2007. Space probes have discovered that the heliosphere is not a perfect ball around the Sun. Its southern boundary is 10 astronomical units closer to the star than the northern one. So, we are moving in interstellar space and will soon approach the stone wall around our solar system. Another 200,000 astronomical units, and here it is, this stone wall of the Oort cloud. In fact, this is a bunch of asteroids that surround our world. Scientists suggest that the Oort cloud may be the source of comets, meteorites that fall to Earth. But it's so spacious here that we calmly fly between them. Now we are in total darkness. The width of the Milky Way is about 106,000 light-years. It would take billions of years for an ordinary ship to cover this distance, but we step on the gas and expertly fly past the stars and planets, as if we are rushing along a racetrack. In a few minutes we reach the edge of our galaxy. There is no interstellar wind here anymore. All you see are bright dots in the distance, and these dots are huge galaxies. You need to look at the map to pave the way to the edge of our universe. We are here next to the galaxy, the Milky Way. It enters a cluster of galaxies, which is called the Laniakea supercluster. But now this hulk looks more like a small street in a big city. By zooming out, we find superclusters of the Hydra Centaurus. Thousands of galaxies on the map look like small dots. Zoom out to the limit, this is our entire visible universe. We thought it was endless. But soon we may have evidence that it has a limit. She's here 10 billion light-years from our home. Even if you travel at the speed of light, it will take twice as long to travel as our planet exists. During this time, the sun will either disappear or explode like a supernova, destroying our entire solar system. If you can suddenly live that long and then return home, you will see that our galaxy is no more. It has long collided with the Andromeda galaxy and they merged into one large cosmic body. Fortunately, our ship is able to bend spacetime in such a way that the journey will take literally a few seconds. Boom! Congratulations, we have arrived at our destinations. This is a relict cold spot or super void of Eridani. Some scientists consider this place to be evidence of a collision of our universe with something huge capable of leaving a giant scar. The super void of Eridani is an empty and cold space 1 billion light-years wide. If you imagine this void as a cup, it would fit at least 10,000 galaxies, and it appeared after some kind of catastrophe of incredible size. The object that crashed into our universe was another universe. Yes, other universes can indeed exist. Imagine that our universe is a huge bubble containing all the clusters of galaxies in the observable universe. There can be an infinite number of such bubbles, and all of them could have appeared during the Big Bang. These universes may be different from ours. There may be other galaxies and nebulae in them, but these bubbles can also be parallel universes. Imagine that in the morning you chose cereal instead of oatmeal, and in another universe your twin chose oatmeal. Every choice you've ever made in life in a parallel universe has completely different consequences. And since the choice is infinite, there may be a whole infinity of parallel universes. Okay, like an ordinary bubble, our universe has a wall that is located next to the supervoid and Eridana. A long time ago, another one flew past our bubble, and when they got closer, their gravitational fields began to interact. Our wall began to deform and stretch to the neighboring universe. The same thing happened on the other side. Then the walls of our universes touched, but as the bubbles moved, their connection began to break and another universe tore off a huge piece from ours. Together with the collision, a cold void was formed, the same void above the void of Eridanus. The problem is that the universe looks the same to an observer regardless of the point of view. Imagine a basketball hanging in the air. If we put an ant on the ball and ask it to find the edge, it will just start running around the ball making an infinite number of circles, but the landscape around the ant will not change. All he will see is a rounded horizon. This is because the ball remains unchanged from any point of view. The same thing happens to us when we try to find the edge of the universe. The fact is that we imagine the world in three-dimensional space. For example, you see an ordinary square in two-dimensional space, but if you add depth and change the point of view, you get a cube. If we could see the universe in four-dimensional space, the square could become something completely different. Perhaps someday we will be able to leave our bubble and the key traveling to another universe will be inside a black hole. Black holes are one of the most mysterious objects in the universe. They are so heavy that they distort not only space, but also time. It's like putting a heavy stone in the net. It will sag, and the closer you get to the stone, the stronger the curvature will be. If you get into the gravitational field of a black hole, you will not be able to leave it. We still don't know what is actually in black holes. Some scientists believe that there are also white holes. Theoretically, they should arise together with black holes. By their direct opposite, nothing can come close to a white hole. There is no data on such objects yet, but the general theory of relativity assumes that they exist. There is a theory that black holes can be passages to another universe. It turns out that if you get into a black hole, you can exit from the other side, through the event horizon of the white hole, bypass the boundary of the universes and find yourself in a completely different world. Perhaps we already have proof that a white hole exists. In 2006, scientists discovered an unusual burst of energy 1.6 billion light-years from Earth, and this explosion was unique. It didn't look like a supernova explosion, or a merger of two black holes. Some astronomers believed that this was the birth of a white hole, but because it was unstable, it disappeared almost immediately. This process resembled the birth of our universe, the Big Bang. Therefore, scientists called it a small explosion.